So that's pretty interesting. So anyway, let's take a look at this first question here. Let f be the function defined there. We also have a function h here, and we have a function g and g prime. Okay, one is a table of values, the other a graph, and the other just a plain old function. All right. They also tell us that g is differentiable. Okay, that's important because when you say that g is differentiable, right, they also are telling you that g is continuous as well, which is important if you're going to need to use something like the mean value theorem, the intermediate value theorem, okay, the Rolle's theorem, and different things like that. All right. So anyway, they're telling us that h is the graph given, 5 line segments there. All right, it's shown. First question is find the slope of the line tangent to the graph of f at pi. So here's f, right? So that one's going to be a pretty simple question. We all know that in order to determine a slope, we just need to differentiate and evaluate at that location. So I'm going to do f prime of x. And this is a very simple derivative. This is elementary. Sine 2x. And then you also have to do the chain rule. And so there's actually going to be a 2 in there. So it's a negative sine 2x. All right. And then you're going to add to it the derivative of e to the sine x. And, whoop, I don't know what happened there. Sine x times the derivative of the exponent, which would be cosine x. Now, I'm going to evaluate this at pi. And we're going to get a negative 2 sine of 2 pi plus e sine of pi times cosine of pi. Now, the angle pi is here, and its x coordinates are -1, and its y coordinates are 0, right? Because its up and downness is nothing, so it's 0, and its left right is fully left. 100% of it is in left direction. So there it is. So the sine of, sine of pi is going to be a 0, and the cosine of pi is going to be a -1, right? So, and then let's figure out what the sine of 2 pi is. The sine of 2 pi is 0. So the final answer is -2 times 0 plus e to the, what did we say sine of pi was? 0 times cosine of pi, which is -1. E to the 0 is 1. This is 0. Looks like we're going to get a -1. -1. That appears to be f prime of pi. Okay. Now, part B. Let k be the a new function here. Oh man, they're introducing a brand new function. They've got f, k, h, j. No, sorry, g. They have a brand new function here. Okay. Question is, what is h? Find its derivative. Okay. Well, this is going to be clearly a chain rule. So k, right, prime of x is what we're going to need to find. And then we'll evaluate it at pi afterwards. It's going to require us to do an h prime of f of x times f prime of x. And this is just your classic chain rule because you have a composition of two functions here. So h prime of x times f prime of x. All right. So that's what that one is. And what we're going to do now is, let's move this stuff over here. Too many monitors. Okay. Now, so h prime of f of x. Well, what I'm going to, I'm actually just going to plug my pi's in here. Times f prime of pi. F prime of pi we already have. We figured it out up there. So we're going to reuse that information. So that's just going to be a -1 when I get to it. But now I want to find h prime of f of pi. Well, we need f of pi. F is here. So I'm going to write a little comma, and I'm going to write f of pi is just simply going to be the cosine of 2 pi plus e to the sine of pi. Now, again, that's just using f and plugging pi in for x's, for the x's. Cosine of 2 pi is going to be 1. And because remember, 2 pi is over here, and the x coordinate is right there. My y coordinate is 0. So sine of pi is 0, right? So I'm again getting a e to the 0. So it's 1 plus 1 or 2, it appears, right? So we got that, all right? Now, sorry, close my door. I'm not sure if you guys can hear that. Hang on. Okay. So now that's what we got. All right. So we know that f of pi is 2. So I'm basically going to evaluate h prime of 2 times, well, f prime of pi is -1. -1. We already know that because that's from up here. But how do I find h prime of 2? Well, h prime, h is up here, okay? And h prime is going to be the slope of this guy, okay? And it's all going to be happening at 2. So here's 1, here's 2. I need to figure out the slope of this line. You can clearly see that the slope of this line is, you know, rise of -1 and run of 3. So it's a -1/3. That's my slope here. So h prime of 2 is a -1/3 times a -1. And so it looks like I'm getting a 1/3 in total, okay? That's pretty exciting. So now let's do this one. M, oh, a whole brand new function. This is a brand new function. And it's going to be like this. So m of x is going to be g of -2 x times h of x, okay? I have to find m prime. So m prime of x. Now, I have to find m prime of 2, but let me find m prime of x first. So this is a product rule. So again, this is just going to be g prime h, you know, plus g h prime, okay? Well, g prime is just going to be, now don't forget, look, there's a function in here, an entire function. So this is going to be a chain rule. So when I figure out g prime of, well, just g prime, note that there's a whole function here. So I'm going to have to chain rule this. And so this is actually going to be a -2 times g prime, okay, of -2x times h of x plus just regular g, so g of 2x plus, times h prime of x. So you might be saying, okay, what happened here? I'm basically, here's g, remember, right? So g is just, or well, I guess g is this little bit of a function in here. So m actually has g of a function within a function, okay? So you need to use the chain rule here. A lot of people would forget this -2 out here, all right? So now this is pretty simple. We're just going to do g prime of a -2x, but we actually want m of 2 right now, right? So this is still m prime of x, but I'm going to do m prime of 2. So it's a -2 times g prime of -4 times h of -2. Sorry, this is a +2 here. +2 plus g of, is there a negative? I missed a negative there. G of a -4 times h prime of 2. So what did I do there? I just, so this is pretty heavy on the notation as well, right? So you got to understand your notations here. This is m prime of x, but I'm taking all these x's and I'm replacing them with 2's, all right? And now I got to just figure out all these values here. So it's a -2, g prime of -4. Well, let's go up here. We're going to do g prime of -4 happens to be a -1. All right. So I'll throw that in there. -1. H of 2 is going to be the value of the function, not the slope, right? Because that'd be h prime. So we're doing h of 2. So it's the value of the function at 2. So it appears to be -2/3, which is right there. We know for certain it's -2/3. It's right here, right? We know for certain it's -2/3 because our slope goes down 1/3 every x value. So what did I say there? So it's -2/3 plus g of -4. So g of -4 is about a 5. Okay, so g of x, so g of -4 happens to be a 5. And h prime of 2, we already figured out h prime of 2 up here. It was -1/3. Same reasoning as before. And we've got some stuff here. That's it. Apparently, we're going to get a total of -3 there. Okay, that's pretty cool. That one was pretty exciting. A lot of different things here. That was a product rule. Okay, a chain rule. It was a strange way of doing a chain rule. Okay, and then pulling information off of a chart and a graph, and then obviously the function as well. Although this didn't use the function, this particular section. So question is there a number c in the closed interval from -5 to 3 such that g prime of c is equal to -4? Justify your answer. All right. So this one is very tricky. Well, it's not too bad. But there's things I need to point out here, special bits that I need to point out that we want to be able to do. Okay, so this one is going to use the mean value theorem, right? Okay, which is, in order for us to use the mean value theorem, therefore what we basically need to be looking at here is that the fact that it's continuous and differentiable. Okay, Rolle's theorem also needs to be continuous and differentiable. The intermediate value theorem only needs to be continuous. Okay, and here's some notes about those different things, right? This mean value theorem means that there is a value c, right, such that it's the average there. Okay. Ooh, f prime of c. I think I missed my prime there. Let's see, where are we at? So in order to do this, I'm basically going to say, all right, I'm going to invoke the mean value theorem. So I have to say that G is differentiable. Differentiable. Nah, didn't spell that right. And it's continuous on the interval from -5 to 3. Okay. In order to use the mean value theorem, I actually need to write it, right? So now that I've written that, I can invoke the mean value theorem, meaning that if I evaluate G of -3, or basically if I find the average rate of change here, so I'm finding the average rate of change between 3 and -5, right? -5 and 3, -3. It's supposed to be a +3. And so I need G of 3 and I need G of -5. Well, that stuff is again back up here. So G of wait, is that supposed to be a -3? It is a -3. Sorry, guys. Because there was no 3. Ha! So I was like, what? My 3 was missing. I had written it badly. So there was a -3 here. Sorry, guys. Because it's from -5 to -3. All right. And so I need a G of -3 and a G of -5 here. So G of -3 is going to be 2. G of -5 is going to be 10. So 2 minus 10 over a -3 plus 5, -3 plus 5, which is apparently around somewhere around a -4. Okay. And so we can conclude, yes, there is a slope of -4 because due to the main, they actually gave you the answer here. Look, they're saying that the G prime of C is -4, which is what you get there. So you are guaranteed by the mean value theorem to have some value C here such that G prime of C is equal to the average rate of change of the entire thing. So that's what your justification is, right? So you would say by the mean value, I think you can do MVT even, right? They kind of accept that on the by MVT, all capitals, right? There exists a C, such that f prime of C equals a -4. You cannot invoke the mean value theorem, though, unless you actually have written down the fact that G is differentiable and continuous, okay, on the interval that is being spoken about. All right, how do I know that? It says up here, G is differentiable. How do I know it's continuous? Remember, in order to be differentiable, you must first be continuous. All right, so there, that's that one. So just as a quick reminder here, this must be stated. This is your justification in this area. All right. Okay. And this is just some calculations that you have to show as well. All right. Now, I wanted to go over this. Hopefully, do I still have this open? Let me see. I got so many things open, guys, here. I do. Okay. So let's look at part A. Part A is worth 2 points. Okay. And you get 2 points. So I'm trying to explain to you guys here. Look, somebody's going to now, so this is your work. Pretend like you did this on the AP exam. All right. Now somebody's going to sit down and grade this. And they're going to have this piece of paper in front of them right here. This one. This is the scoring guidelines. All right. So they sit and they say, all right, this is worth 2 points. You get 2 points for doing f prime of pi. Okay. Well, you probably get a point for f prime. And then you also get a point for actually writing down f prime of pi as a -1. So the question is, did I do that? Did I do that correctly? All right. I wrote down f prime here. And then I wrote down f prime of pi is -1. Okay, so we got our 2 points there. All right. Now, next one, part B. Let's see what kind of points we get. For part B, we get, again, 2 points. 1 point for k prime of x, and another point for writing down k prime of pi. So here's your actual point. Notice how, look at that. Where did I write that? Did I write that somewhere? Right here. You actually, they actually kind of wanted you to write this out in order to get that point by actually writing out the usage of the chain rule, right? They really like it when you write out fancy notation like this, all right? They give points away for that kind of stuff. And then obviously you also get a point for the solution here. Now, I also wanted to mention, as far as I know, you, let's see, you see how I wrote, well, I guess that's good. I'll mention it later. I'll mention it here, actually. You see this, as far as I know, this could be considered a correct answer, okay? Right there. Now, I wanted to also mention this is not a correct answer just yet. So they want you to figure out things like cosine of 2 pi and sine of pi. So you would actually have to write down this, in which case, at least that. And 1 plus 1 is a correct answer. You don't actually have to write down 2. Just like over here, if I write all this down, I don't actually have to write down -3. All right. So I just wanted to mention that to you guys. It's something that weird. They don't make you simplify if your answer has already all of the numbers in it. Okay. Now, let's look at part C. Where do I get my points? I get 3 points, 2 of them for figuring out m prime of x, which is this thing. Okay. Now, where do you get those 2 points? You probably get a point for knowing to use the product rule. And then you probably get another point for this little section right in here. Remember, I was telling you that a lot of people would miss the chain rule here. So you would get another point for this chain rule here, okay? And then you would get a point for actually evaluating everything and bringing it down to this far, all right? And you would get your 3. Did I write -3? I did, okay. So now the tragedy in this is that, let's say I didn't write this -2 here. Unfortunately, you would probably get a point for the product rule, for if you were to write the product rule. You would miss the point for the chain rule, and then unfortunately you would also miss the point for this point right here, this point right there. Okay, so that one little 2 right there could end up giving you only 33% of the total allotted points on this question. Now, let's look at part D. G is differentiable, G is continuous. You have to actually write that, okay? Actually, I didn't write this little arrow here as like a it implies. So it's probably, I should go back. Not sure I would get points for that. Actually, look at that. I say G is differentiable and continuous. I think they might actually want you to write it like this with like an arrow, therefore type thing, or like 3 dots, therefore, right? So now we've got that. So that's, now I bust out the mean value theorem, okay? So you get a point for that. And your 1 is your justification for using the mean value theorem, okay? So therefore, by the mean value theorem, there's at least one value C. You're basically just restating the mean value theorem here, okay? And you can't do that unless you've written down the conditions for the mean value theorem being a thing, all right? So that's that one, all right? Now, I actually have another one that we can do. This is number 5. This one is going to end up using the L'Hopital's rule, right? This is number 5. When was this? This previous one was 2017. So this one here, the one that we just did, is number 6, I believe. Free response question on the 2017 AP exam. This one, the next one, I think it's number 5 on the 2018, right? So 4 or 5 years ago, these were. So question is, here, they give us a function, f of x. It's pretty easy. Find the average rate of change. Okay, so we know that the average rate of change is going to be the quotient, difference quotient, right? So my average rate of change is going to be f of 0, pi, minus f of 0 over pi minus 0, okay? Now, that's pretty simple. So I'm going to go ahead and do my f of pi. So it's e to the pi cosine pi minus f of 0 is e to the 0 cosine 0. All right. All of that over, what are we given? A pi here. Okay. So I'm going to leave my pi on the bottom. E to the pi, well, that's pretty okay, but let's see what's cosine of pi. We got to remember so here's pi again. Cosine of pi has an x coordinate of -1. So remember, cosine asks us to get the x coordinate of the angle. So that's going to be a -1 there. It's a negative e to the pi minus, which is this one here, cosine of, oh, I forgot to write a pi here. I don't know. I wrote a theta. This is supposed to be a pi. Again, a cosine. E to the 0 is 1. This is a -1, so that's going to be a. Oh no, it wasn't a theta. It was a 0. Sorry, I thought it was a theta. Cosine of 0 is 1. All right, so 1 times 1 is 1. That was tricky. I almost messed that up. Okay. Question is, what is the slope of the tangent line? So again, this is a pretty easy one. I'm going to take my function, evaluate it at its derivative at 3 pi over 2. Okay. Now, so my f prime of x is going to be a product rule. So e to the x cosine x plus e to the x sine x, and I might as well make that a negative because the derivative of cosine is a negative sign. Here I differentiated e to the x. Here I didn't differentiate cosine. And again, I e to the x and I differentiated there. So now the question is what do I want to do with this? I want to evaluate this at 3 pi over 2. So f prime of 3 pi over 2 is going to be e to the, 3 pi over 2 cosine of 3 pi over 2 minus e to the 3 pi over 2 and sine of 3 pi over 2. Now, question is, what is 3 pi over 2. That's this angle here, which is negative x coordinate of 0, y coordinate of -1. Okay. And so when I go to figure out my cosine, it's going to be a 0. When I go to figure out my sine, it's going to be a -1. So this whole term goes away, this first one. This one turns out to be a -1. So it's just going to be a positive e to the 3 pi over 2. That's my slope. Put an equal sign there, I think. It's probably a good idea. And there. Or you could even do it over here, I guess. Probably do it over here. E to the 3 pi over 2. Maybe that's the best way to do it. There, it's nice and clear. All right. Should be okay. Now, what are we looking at? Looking at part C. Absolute minimum value. Justify your answer. We got to justify this. So figure out the absolute minimum. What you're going to need to do is you're going to have to do f prime of x, and you set it equal to 0 and solve. All right. So f prime, do I already have that? I do. It's up here. Okay. So I'm going to take that and I'm going to set it equal to 0. So it's going to be e to the x. Then I've got cosine x minus sine x equals 0. I just factored out my e to the x there. Now, according to the zero product property, you can set either one of these. So cosine of x minus sine of x equal to 0. Okay. This guy has actually no solution right here. No solution. This one is pretty interesting, actually, how it turns out. You have to logic your way through this. Cosine of x is when does cosine of x equal sine of x? And we know that that occurs at these two angles. So at pi over 4 and 5 pi over 4. So that's when the cosine and the sine of the angle are equal, right? So it's like, what angle can I put here and here such that when evaluated at cosine and the same angle evaluated at sine, I get an equivalency, or I get the same thing. So there it is. I got two solutions, that one and that one. Okay. Now, the question is I have to find my minimum. Well, when you find your absolute minimum, you actually also need to check out the endpoints. All right. So I'm going to write down 0, right? I'm going to write down pi over 4, 5 pi over 4, and 2 pi. Okay. And I have to figure out the f. Oops. I don't want to write that there. This is my x value. This is my f value. Okay. And so basically what I'm going to do is I'm going to take not the derivative here, but I suppose the original function, which is way up here, e to the x cosine x, right? So this is going to be e to the 0 cosine 0, right? E to the pi over 4 cosine of pi over 4. Oh, I don't know why I wrote it so high there. It needs to be written here, pi over 4. Then it's e to the 5 pi over 4 cosine of 5 pi over 4. And then e to the 2 pi and cosine of 2 pi. Question is which one of these is the smallest? Okay, this is the smallest because this is only, each one of these are going to be positive values. I keep writing theta here. This is supposed to be a 0. So basically I can write whatever, I don't know, cosine of 0 is 1. And so this is just 1. Okay. And then what is this? Cosine of pi over 4 is the x coordinate of pi over 4. So it's square root of 2 over 2. So this is equal to root 2 over 2 times e to the pi over 4. This is equal to negative root 2 over 2 times e to the pi over 4. And this is equal to e to the 2 pi, because cosine of 2 pi is 1. So the question is we want the absolute minimum. Absolute minimum is going to be this one. So you're going to have to write that. Negative root 2 over 2 times e to the pi over 4 is the absolute minimum, right? And this right here, I believe, should be sufficient justification. Later on, we'll check out the scoring guidelines so that we'll see kind of what they think about that, right? But I think if you wrote pretty much what you're looking at right here, then you should get, unless I made a mistake somewhere, we should get all the points available for this section. Let's look at part D. All right, get G is a function. Okay, so there it is. They tell us that G of pi over 2 is 0, so maybe some information is going to come in handy later. They also give us the graph of G prime. Okay, it's G prime. Now be careful. I've seen a lot of students misinterpret. If they give you a derivative graph, a lot of students think that this is just a regular G graph, okay? Not, so this is already, this represents the slopes of G, okay? So you gotta really be careful when they're, so you could miss, if you interpret this graph as G rather than G prime, you could potentially miss a lot of points in this question, okay? So let G be differentiable. Okay, so it's a differentiable function. Graph of G is prime is given. All right. Find the value of the limit. Here we go. So the limit as x approaches pi over 2 of f of x over g of x. So the limit as x pi over 2 of g of x. All right. So one thing I want to mention, notice I wrote these separately. I wrote these each separately. What we want to do is we want to figure out each of these limits separately, because this is going to be almost certainly a L'Hopital's rule. So remember, you got the quotient here of a limit. You're probably going to get a 0 over 0 here, right? They like this rule on the AP test, the L'Hopital rule. So what you have to do is you have to actually state the value of each of these limits, all right? And you know that if you got a 3 here and a 5 here, then the limit is 3 over 5. So anyway, let's look at it here. What's F? What is F? This is a part D. So F is given way up here. Where is F? Where is it? Here it is. E to the x cosine x. So it's basically e to the pi over 2 cosine of pi over 2, which is, what's the cosine of pi over 2? That's 0. All right. Now, so that limit is 0. So this is already, it's begging you to use the L'Hopital's rule. You say, the numerator is 0. Let's see. If the denominator is also 0, then you're good to go. Now, well, it's actually going to be g of pi over 2, which is 0. All right. Note that g is continuous. Actually, no. You want to write G is differentiable, and therefore G is continuous at pi over 2. I guess I should write x equals pi over 2. Now, why do we need that? Because remember, your limit doesn't necessarily equal 0, because they didn't tell you the limit equals 0. Look at this. They told you that the value of the function at pi over 2 is 0, which isn't necessarily the limit. Because, for example, let's say that this is pi over 2, and let's say that this is 0. I'll just put it up there just for fun. If my function looks like this, right, then we know that, yes, g of pi over 2 could equal 0, because g of pi over 2 equals 0. But it doesn't necessarily mean that the limit of g of pi over 2 is equal to 0. So this is a tricky question, because you actually have to justify. You can't just say that the limit is equal to 0 because the function equals 0. It only limit is equal to 0 if the function equals 0 and it's continuous. Okay, so why is it continuous? Because it says that it is differentiable. Mega trick question here, or it's not a trick question. They're just setting you up to potentially make some assumptions that are going to be correct, but you have to justify it. All right. Anyway, so look, now that we've justified that both of those are 0, we can now write that we can use L'Hopital's rule. Okay. Now, why can I use L'Hopital's rule? Because I have actually written somewhere on my paper these two things, that this limit is 0 and that this limit is 0. You can't just use L'Hopital's rule if you don't physically write down the fact that the two limits in the limit in the numerator is 0 and the limit in the denominator is 0. I've heard, by the way, that if you write this, this is not valid. This is limit x equals pi over 2 of f of x equals g of x equals 0 over 0. A lot of people write this, but apparently you may or may not. Some people have told me that if you simply write this, you're going to lose points. You actually have to write, see I've written them separately like this? It's crazy, right? But they want it written separately. This is apparently not good enough to invoke L'Hopital's rule, right? So if you're going to write it, if you're going to use L'Hopital's rule and you want to guarantee you get the points, make sure you write each of these things separately. Now, where am I? I'm using L'Hopital's rule. So what do I have to do? So now, in order to use L'Hopital's rule, I can say that the limit as x approaches pi over 2 of f of x over g of x is equal to the limit as x approaches pi over 2 of f prime of x over g prime of x. And this one, I can actually now write out the numbers. If I get a 0 over 0, I'd have to rewrite every limit. Sometimes you have to use L'Hopital's rule twice, okay? So f prime of pi over 2. So I'm going to write down, this should be f prime of pi over 2. This is going to be g prime of pi over 2. If neither of these are zeros, or I guess if they're not both zeros, then what I've written here is still okay. If they turn out to be both zeros, then I have to kind of take these away again and rewrite them separately like I did up here. Okay, but that's not going to be the case, I think. So I'm going to get f prime of pi over 2. What is f? What is f? Again, f prime is way up here. Where is it? Where is it? Here it is. E to the x times cosine minus sine. That's right. So let me write that. So it's e to the pi over 2 times cosine of pi over 2 minus the sine of pi over 2. And now I got g prime of pi over 2. Look at that. G prime of pi over 2 is going to be 2, right? Right there. Where would people go? Let me get us the answer here real quick. So e to the pi over 2 times, what's this going to be, a 1 or something? Cosine of pi over 2 is 0 minus 1, so negative. Oh, my pen went wild there. Oh, got to close out my thing, open it back up. There we go. Okay. All right, so now what did I just do there? Sine of pi over 2 is 1, so this is a bit of a negative. There's my limit. Great. Hey, by the way, why is this 2? Because g prime is just totally given right here, right? So what people would maybe make a mistake here is they would write, it does not exist on the bottom. Right here, does not exist. And then they would maybe conclude that the entire limit doesn't exist because g has a kink in it. And as we know, the limit, it's not, that means it's not differentiable. Well, you actually might, the limit of g, but we were talking about the g prime. Yeah, no, if you had assumed that this was g, right? You might be thinking, okay, I need to figure out the limit of g prime here. You say, okay, well, that would be the value of the slope as I approach pi over 2 from the left, and the value of the slope as I approach from the right, and they are not equal. And I could therefore conclude that the slopes are different on the left and the right, and therefore it does not exist. That would be true if this was the graph of g, but this is the graph of g prime, and so they actually just give me the number there, okay? Anyway, so I want to go over the grading scheme again really quickly. Got about 10 minutes left here. Hopefully I can do this. Did I get this question? I did. Okay, cool. Here's our scoring guidelines. All right. Scoring guidelines. So here it says the average rate of change of f on this interval is given. So you get 1 point for this, okay? Now, from what I heard, they actually like it if you write this thing down, the actual difference quotient, though I don't know that it's fully necessary. But I would go ahead and write that. I think they like to see that. Now, B, apparently you get a point for the derivative. And then you get a point for evaluating the derivative and actually writing the slope down. All right. And the slope of the tangent line of the graph. Actually, I think they like it if you write that down. Look at that. You know what? I might have missed some points there. Look at this. Let's go back up to part B. Find the slope of the tangent line. Now, I would say the slope of, f at x equals, I know it's annoying and you might forget to do it, is e to the 3 pi over 2. But hopefully you kind of have some extra time and you can maybe, in a way, deal with that. So here we go. For part C, you know, they're telling you, okay, look, your derivative needs to be equal to 0. So you solve for that and you get your two answers. Then you have to identify. So those are your candidates. Those are your, like, your critical points right there. Okay. Now, the other thing is don't forget, you also have to justify this by checking the endpoints. So you can't just check these two, all right? Because if you would have just checked these two and you would have written that and circled that, you would have gotten the right answer. But I believe you would have missed the justification section here because if you had forgotten to check also the endpoints of the interval, right? So that's what I'm talking about right now is this one right here, okay? And there you go. E is the absolute minimum. You probably also should write down the interval from 0 to 2 pi. And by the way, I think you actually can just use words like this, from 0 to 2 pi. You don't actually have to write it down in this notation here. Last thing, you get 3 points for this one. This was 3 points, 2 points. They're all worth 9 points, by the way. 9 points. 3, 3, 2, and 1. So a total of 9 points. The previous one was also worth 9 points. Here, look at this. Notice, look, in order to use L'Hopital's rule, look at, they wrote separately in 2 separate lines that each of the limits was equal to 0. So once you've written that, you can then invoke L'Hopital's rule, okay? And you can simply just write this. You didn't even, look at, I even went a little overboard and I wrote down the entire derivative here and this, but you can actually just go for the answer if you don't, but right? So this is L'Hopital's rule. You want to write this, you want to write that, and then you want to write, the answer. Like these two things right in here are not entirely necessary, but you can write them. Okay. But the one thing you did not want to miss is this stuff up here. Oh, I didn't show you. It's this stuff up there. Okay. Oh, I think I erased that stuff. But anyway, I think you know what I'm talking about. Okay. So yeah, that's pretty exciting stuff.